Good morning, students. Welcome to the Science 1 class. Today, we are going to see about the definition for vapor density and relative molecular mass. Once we know the relation between vapor density and relative molecular mass, we are going to derive the same relation with Avogadro's law application. So, let us start the basics. Density is nothing but mass divided by volume. Mass is measured in gram, volume is measured in cubic centimeter or centimeter cube. Relative molecular mass is nothing but molecular mass. This is the mass of molecule. The word means relative, means we are comparing with some other atom. For example, hydrogen or carbon 12 isotope. So the carbon 12 isotope usually we do now, whereas the hydrogen we use previously. Now in this concept we use only hydrogen scale. Relative molecular mass using hydrogen scale. We going to is. We should know the next concept, ideal gas equation. PV is equal to nRT. P is the pressure, V is the volume, N is the number of moles or is the gas constant, T is the temperature. Next we are going to talk about small n. Small n is the number of moles. Number of moles can be calculated using by the formula small m divided by capital M. Small m is m mass, capital M molar mass or molecular mass. This formula we are going to use instead of n. Let's we go the derivation vapor density with relation with molecular mass. We know density. Density is equal to m by v. What is called vapor density? When I say vapor, so this is applicable only for the gas. So that we have to very carefully vapor density, otherwise called relative vapor density. What is meant by relative? Relative means comparing. So we are comparing with some other. Then you are comparing a substance, remember. So what we understand? So vapor density is nothing but density of substance or gas divided by the density of hydrogen atom, standard temperature and pressure. So wherever you come across STP, which means standard temperature and pressure. So we comparing the density of gas with density of hydrogen. In some cases, the density of the hydrogen is replaced by air. So this is very important, my dear students. This concept used in firefighting scenarios. Let us take a gas. The density of an inflammable gas is less than air that will rise up. Whereas the density of gas is higher than the air, it will come to bottom. So in the fireplace scenario, what will happen? The density of air is less, so mostly the flame is going up, right? So the firefighters exactly know where fire with a higher density. They put off the fire very easily. Using this concept, this idea is very helpful, my dear children. The vapor density is nothing but the density of gas by density of the hydrogen and STP. In some case they will use air, got it? In this scenario we are going to use only hydrogen. From the ideal gas equation we know very well that PV is equal to nRT, which we have seen in the last slide. Now instead of this n, you will substitute m divided by capital M. So we get PV is equal to m RT divided by capital M. Now we can interchange this V and molecular mass. Pm is equal to small m divided by V or T. What have we seen? M divided by V, that is nothing but density. But instead of this Pm, we will write d or T. So Pm is equal to d or T. From this, what we have got is density ideal gas equation with density involved that we are going to use for the equation. For any substance will gas, we can write PMS is equal to ds or T. MS is the substance. Similarly, for hydrogen also we write then PMH2 is equal to DH2 or T. So only molecular mass of the density will vary, remain others constant. For hydrogen gas, remember from that what I require only ds. So we can interchange other criteria so that ds equal to PMS divided by RT. Similarly, in the second case, PMH2 is equal to DH2 RT. So we interchange this. DH2 is equal to PMH2 divided by RT. In order to calculate the vapor density, what we have to do? We know the density of gas is equal to density of hydrogen. So we substitute the equation. So we will get Vd is equal to PMS divided by RT whole divided PMH2 divided by RT. When you common, you strike out P RT. So finally we get MS divided by MH2. Now vapor density is equal to molecular mass of substance divided by molecular mass of hydrogen. We know that the molecular mass of hydrogen is 2. So molecular mass of substance divided by 2 is nothing but vapor density. So vapor density is equal to molar mass of substance divided by 2. Or else if we cross multiply this 2 here, we get 2 into vapor density is equal to molar mass of substance, right? The now definition we will write. The density of the gas is equal to mass of gas divided by volume of gas. The density of hydrogen is equal to mass of hydrogen divided by volume of hydrogen. So with this we are going to write the definition of vapor density. Now let's see the vapor density definition. Now what we have seen, vapor density is equal to density of the gas divided by density of the hydrogen. From this density definition, we are going to write mass of certain volume of gas at STP divided by mass of same volume of hydrogen at STP. This is the definition for vapor density. How will you say this in words? Vapor density is defined as it is the ratio. Remember, two mass we are comparing. So it is the ratio of the mass of certain volume of gas to the mass of same volume of hydrogen at STP. So this we have to understand. Now next in relative molecular mass. I told you already what is called relative. Relative means comparing with what we are comparing, hydrogen. For RMM is nothing but the mass of one molecule of substance divided by mass of one atom of hydrogen. So what is the mass of one atom of hydrogen is nothing but 1 U. So there is no unit for RMM. I hope this definition is very helpful. You are understanding this term vapor density and relative molecular mass. This will be used application of Avogadro's law. Thank you students. Have a good day.